consider an example. Now, we are given the following function values of fx, an unknown function, okay, or complicated function. We don't know the formula of fx. We only know several discrete points. Now, you see for xi equal to 1, 2, 3, and we are given the three function values are -1, -1, and 1. It's okay? So I show you the figure 1, 2, 3. Okay, -1, -1, and 1. For example, okay, -1 should be here. -1, -1, and 1. Okay, here this is x, and here is 0. Then here is y. It's okay. Then now you see that means we need to find a parabolic curve like this. Okay, satisfy the three conditions, passes through the 3 points. Okay, now we don't solve the linear system at the beginning. We know we can directly write the functions, right? Okay, now we find because there are 3 nodes, so the number of nodes -1 is the degree of the polynomial, right? So quadratic polynomial denoted by P2x. Okay, then if we find P2x, then we can approximate f function value at 1.5 by using P2x, right? Okay, so now firstly, let's practice. We determine the Lagrange interpolation basis, 3 bases, right? Okay, L0x, let's practice. Please follow me, okay? It should be a ratio, right? What is the numerator? The numerator is x minus other nodes, right? So for L0, okay, so you should, because here we use 1, 2, 3, and so x0 is 1, x1 is 2, x2 is 3. It's okay? I just show you the discrete points. So for L0, then should be x minus other nodes. So x minus, because this is focused on x0 is 1. So for other nodes, they are 2 and 3. So directly here, x minus 2 multiply x minus 3. It's okay? The numerator. What is the denominator? Denominator just replace x by x0. Here, x0 is 1, right? So it is 1 minus 2 multiply 1 minus 3. Clear? You should understand the rule. Then you can write it quickly, right? Okay, actually, you see, 1 minus 2 is minus 1. 1 minus 3 is minus 2, so the denominator is 2. So 1 over 2 multiply x minus 2 multiply x minus 3. It's okay? Simple function, right? Okay, let's come to L1. L1, so what is L1? X1 is 2. So for other nodes are 1 and 3. So the numerator is x minus 1 multiply x minus 3. Okay, denoted by replace x by x1. You should know x1 is 2 here. So 2 minus 1 multiply 2 minus 3. It's okay? So 2 minus 1 is 1, 2 minus 3 is minus 1. So it is minus 1 multiply x minus 1 multiply x minus 3. Clear? See, it's simple, right? Okay, last, L2. Okay, for x2, other nodes are 1 and 2. So x minus 1 multiply x minus 2. Then replace x by x2. You should know x2 is 3 here. So 3 minus 1 multiply 3 minus 2. Clear? Okay, now 3 minus 1 is 2. 3 minus 2 is 1. So the the denominator is 2. 1 over 2. Multiply x minus 1 multiply x minus 2. Clear? Now we know the 3. So we obtain the 3 bases. So for each basis, multiply the function value 1 by 1 and compute the summation. Then we obtain P2x. Right? It's okay? So I write here firstly, P2 should be, okay, y0 multiply L0x plus y1 L1x plus y2 multiply L2x. Clear? So y0 here, y0 is minus 1. So it is minus 1 multiply this function L0. And y1 is minus 1. So another minus 1 multiply this L1. And y3, this is y1. And y2 should be 1, right? So multiply this function. Then compute the summation. Clear? Okay, so now you see, then we obtain P2x equal to L0x multiply y0 plus L1x multiply y1 plus L2x multiply y2. So L0 multiply y0 minus 1. L2 multiply y1, another minus 1, sorry, okay? And L2 multiply y2, it is 1. Okay? Now you can compute the summation. Okay? So at last, I just show you the result. Okay? Please practice. I show you the details here, but I don't have enough time to explain you in details. So I just show you the final result. The final result is x squared minus 3x plus 1. It's okay? Then we obtain P2. Of course, when you obtain the P2x, please check. Let's check P2 at minus 1, right? Here, P2 at 1. What is the function value? 1 minus 3 plus 1. So it is minus 1, right? It's okay? Satisfy y0. And if we check P2 at 2 is x1. Okay, 2 squared 4 minus 6, it is minus 2 plus 1. Okay, minus 1 again. Right, it's okay. Check the function value. Okay, at last, let's check P2 at 3, right? P2 at 3. So 3 squared is 9. Minus 3 multiplies 3. 9 minus 9, 0 plus 1. So it is 1. Right? You see, check. The function value here is y2 is 1. Now, we checked the 3 conditions. So this is unique quadratic polynomial, right? P2. Okay, that means we can use P2x to approximate the function fx. Now, if we want to find the approximate value of f at 1.5, then because we know the sample function P2, so we can directly compute P2 at 1.5. Then that means 3 over 1 square minus 3 multiply 3 over 2. 3 over 2. Okay, plus 1. Then you can obtain the answer is minus 1.25. That means we can use this value to approximate the unknown value. It's okay? So this is interpolation approximation. Interpolation means we are given the discrete point, right? We can find here I show you the figure again. What is interpolation? Here you see, interpolation approximation means we are given several discrete points. We find a simple function px. Okay, polynomial formula, for example, then interpolate these points. Now, then we can use this simple function to approximate this complex or unknown function. It's okay? So this means interpolation approximation. It's okay?